So this time we're going to take a look at the vessels themselves. We know that the heart is the pump, and now we're going to see, okay, how are our vessels? Tell me about the anatomy of these vessels you speak of. And I have this visual here just to remind you that the vessels are, we're going to put them into categories based on structure and learn about the structure of these vessels. But the vessels are one continuous tube. Think about that for a second, that branches in like bajillions of different ways. Don't get lost in, don't lose that big picture in all these details that I'm about to give you. This visual is nice because it shows you how, we start out, here's my heart, and we start out with a tube that branches, and all those branches, we've got a new name, and now we've got another new name because we branched some more, and then holy branching madness, new name. And then we feed back in, like now we're unbranching, new name, more unbranching, new name, and then we feed back into the heart. And so this pattern of blood vessel organization is something that we're going to see all the way through, and they're all connected, and they're all filled with blood. Okay, I'm going to make you a chart. The chart is for the stuff that we're, like, what is going to be found in like a quintessential blood vessel. And here's how I want to do the chart for you. I want to do our three main kinds of blood vessels. You remember we've got our arteries, we've got our veins, and we've got our capillaries. And so my chart is going to include boxes for each of these. What I want you to remember, in fact, I'm going to do that just a little bit differently. I'm going to go like this. Since we are branching, our arteries branch into smaller structures called arterioles. And I'm going to write that down here because I don't want you to forget that they exist. However, I'm not going to explicitly put them on my chart. And the reason why I'm not going to put them on my chart is because they're just going to be an in-between transition between arteries and capillaries. And what you'll see is capillaries are super different from everybody. Arteries are different, and veins are different. And then you can imagine these arterioles and these venules as varying degrees of transition between each of these bigger groups. Okay, so let's look at what they're actually made out of. All of our vessels have layers and certain components. We have a fibrous layer. Oh gosh, you know I want to color code it because I can't help it. We have a fibrous layer, and we're going to keep track of who has this fibrous layer you speak of. We also have smooth muscle, and I'm just going to put my smooth muscle like a that because you know smooth muscle already. And then we have elastic, like elastic layer, elastic components. That says elastic. And then we have a substance called endothelium. And endothelium, hopefully you're like, I can know some stuff just by the name. Okay. And I'm going to tell you, I'm going to draw you a general vessel with these parts in it. So generally, vessels have kind of a thick, some of them. Okay, and this is, I'm drawing you this general picture of what the fibrous layer is like. The fibrous layer is connective tissue, which makes sense. It's the most deep from the lumen of the vessel. So I don't have the lumen drawn yet because I'm drawing this fibrous, thick, tissuey layer. The smooth muscle layer is going to be inside of that, and I'm just going to draw my smooth muscle layer looking kind of muscly. Doesn't that look muscly? And we'll look at like different amounts of smooth muscle in our different vessel types. Our elastic layer, the elastic component actually has multiple, like it can be found in multiple places. It can be found inside, like mixed in with the smooth muscle. But I kind of like, when we look at our slides in lab today, we're going to see a really awesome example of an elastic layer. And so I kind of like to have it all defined for you. And the last layer is the most internal, the most luminal layer, and that is called the endothelium. And I'm drawing my endothelium. Hopefully the word itself tells you, like, what is the endothelium? The endothelium is a special name for epithelium that is found lining tubes that are inside your body. Remember how we had epithelium lining our digestive system, but we decided that the digestive tract, the lumen of the digestive tract was outside our body? Donut analogy, remember that? Well, endothelium lines blood vessels, and the blood vessel space is inside your body. Like you can't like jump in the blood vessel and go swimming through a blood vessel and get out. You can totally jump in the stomach and swim through the lumen of the stomach and come out. Hopefully this end and not the other end. But you could come out either end you wanted to. Point is that blood vessels are closed up inside your body. Now, let's see who has what components of these and how much. So first of all, and I'm going to do this kind of diagrammatically so that you can compare and see like how they are related to each other with amounts. So look at this. I'm going to take a little square. Like if my square is this big, it means that arteries have endothelium. And the amount of endothelium that the artery has, guess what, is the same as the amount of endothelium that a capillary has. I want you to take a brief recess and remind yourself, what are capillaries doing? Like, what's the purpose of a capillary? Exchange happens at the capillaries, and we'll talk about the functions of blood and that one of the major functions is to allow exchange. It happens at the capillaries. How can it happen at the capillaries? Well, they have this really thin layer of endothelium. The endothelium is actually simple squamous epithelium, which should be like, oh, well, of course it's simple squamous epithelium since that is about diffusion. Veins and venules all have, that looks a little bit bigger. I'm undoing that. They have the same amount of endothelium. Everyone has the same amount of endothelium. Capillaries have only endothelium. That's it. They don't have elastic layers, smooth muscle, or fibrous tissue. Nope, they don't have it. So we're done with the capillaries. You now know the structure of a capillary. Arteries have elastic tissue. They actually have an elastic layer that is bigger than anyone else's elastic layer. So I'm going to go ahead and draw my elastic layer looking kind of big. Veins also have an elastic layer, but it isn't as big as the artery. So I'm doing it on purpose like this so that you can just kind of visualize the quantities and the differences. Now, arteries are full of smooth muscle. Perhaps I should state that differently. Arteries have a thick layer of smooth muscle. So let's go ahead and draw that in almost like the amount of elastic tissue yeah, this is not accurate. This is relative. So I'm showing you smooth muscle in relative amounts. Veins do have some smooth muscle. I want to make a special note in smooth muscle land for the arterioles. Okay, so look at this. Look at what I'm doing. I'm making a special note for the arterioles. Arterioles have a lot of smooth muscle. What is smooth muscle going to do? Smooth muscle contracting is going to vasoconstrict or decrease the diameter of your blood vessels. If it relaxes, it's going to increase the diameter or vasodilate. The amount of smooth muscle you have in vessels will determine, like you can actually change the diameter of your tube and affect blood pressure and affect exchange in various locations. And so there's a lot of control in arterioles, and we'll talk about this more in physio. There's a lot of control at the arterioles in blood flow. Capillaries, no smooth muscle. Now, my fibrous layer is the same in everybody. It's not the same in everybody. It's the same in the arteries when compared to the veins. So the arteries and the veins have the same amount of fibrous tissue going down to capillaries that have none. They don't have this fibrous layer. There's something else I was going to tell you. Oh, I want to give you some other names. What? Other names in anatomy? The fibrous tissue in all of our blood vessels is called tunica externa. So that's the layer. Like tunica externa is this layer right here. It's the fibrous layer. The smooth muscle is called tunica media. It's the middle media layer made of muscle. Easy. And then we have another tunica that's made of both of these inner layers, and that's tunica intima. Tunica intima. So the most luminal layer of tunica intima is the endothelium, but it also has this elastic layer, and that's included in tunica intima. The last thing I want to do is I want to show you their relative, I don't know, let's do thickness and diameter. And this is a relative measurement because I want you to think of thickness as, of course, thickness is this. And what's diameter? Diameter is the lumen, like the distance across the lumen. And we could throw numbers in there, but who cares? The important thing that I want you to be aware of is relative relationships. Now, arteries, the thickness of the artery is the highest. So I'm going to do 1 equals biggest, and then we're going to go to 3, which is smallest. And so we're going to use the same numbering system for both of these. So arteries have the thickest wall. Veins have the biggest diameter. Capillaries come in last place on all of them. So capillaries have the tiniest diameter, and they have the thinnest walls. Arteries have the second biggest diameter. So veins have a bigger diameter than the arteries, and we can definitely see that in our bodies. And then veins have the second thickest wall. And again, we can see that as well. These are obvious anatomical attributes of vessels. Okay, you're good. Now let's talk, we've got the basics. Now we can get into our blood and figure out what our blood is actually doing and what it's made out of.